Thank you everyone for joining the session. My name is Rohini Gaonkar. I am a senior developer advocate here in AWS India. And today we're going to talk about infrastructure as code, or if I have to say, infrastructure is code with AWS Cloud Development Kit. Before we get into the topic, I just wanted to give you a quick introduction about me. So I call myself I'm born in cloud because I've been working with cloud technology since last decade. As I joined my first company, I was doing a lot of R&D. I was doing a lot of research and POCs around different cloud vendors, and eventually we started a practice, and I was working on migrations towards the cloud, and that's when I actually fell in love with the AWS technology, and I was lucky to join AWS. So I've been with AWS for last 6+ years, doing multiple roles in multiple countries. Majority of it was a solution architect as a role, and I recently this year I decided to move into the developer advocate role because I wanted to give back the learnings that I had over so many years of working with AWS. I just wanted to give contribute back to the community and work with an amazing community that we have here in India. So let's get to our topic for today. That is, AWS CDK or Cloud Development Kit. So what we're going to do is we're going to talk about why you need CDK, what it is. I will also have a small demo about how you work with CDK. Towards the end, I have a quick glimpse into CDKX. I do have a small demo. The demo guys may not be very happy with me. I do keep making some changes, but we'll see how the demo goes. And I'll also share some information about how you can learn, how you can contribute back to the CDK or the open source community that we have around CDK. So let's first talk about why CDK, right? And this is very important to understand the evolution of infrastructure provisioning in cloud itself. Like I've seen the entire journey, right? I've seen from when cloud was just new, from there to today. It's amazing how customers have been interacting with cloud, and how the infrastructure provisioning has changed since then to today, right? And initially, always most of the customers that come onto the AWS platform will always use the AWS management console. Now, that is good, right? Because it's quite easy to get started with the AWS management console. It's quite easy to be able to do few clicks and be able to create IT resources. That could be compute, that could be storage, database, networking, any kind of facilities or infrastructure that AWS provides, or any services AWS provides. It's easier to use the management console to do that. But if, as the application complexity grows, as you want to do more with the cloud, right, it becomes quite difficult to keep doing this manually. You cannot reproduce it all the time. You have to go through the same process, you have to go through the same wizards all the time, and it is definitely time consuming. And most of us, we have been developers somewhere in our lives, right? So like I've done this as well, like write my own scripts where I could call these APIs or use the SDK to call these APIs, and execute my own scripts to do this. So now I can have a reproducible script that I can execute, and I can do the same activities using a script. But then that also had a lot of problems. Like you had to do a lot of boilerplating, right? You had to know what happens if something fails, how do I retry. I have to ensure that I'm catching all these things in my script. I have to make sure there is no race condition, there is no configuration drift. So there was a lot of work that I had to do in the script itself to be able to create my infrastructure. So for creating infrastructure, I'm creating a lot more things on the outside as well, right? And that led to creation of services like AWS CloudFormation, or you have Terraform in the market as well, where you work with YAML or you work with JSON-based templates. You write these templates in a form that your infrastructure is now defined in these templates, right? And you give these templates to these services like CloudFormation, who will then call the SDKs or APIs in the backend and create the infrastructure for you. Now, in this case, the service itself, the CloudFormation service, will take care of the CRUD operations. It will take care of retries. It will take care of error handling, configuration drift. It takes care of a lot of things for you. And you as a person has to write a template in a form of JSON or YAML based. Now, this solved a problem up to a point, because coming from my own experience, right? I said I was a support engineer when I was working in South Africa for AWS, and I was a subject matter expert for CloudFormation. And as a subject matter expert for CloudFormation, I have seen customers enjoying CloudFormation, but also dealing with a lot of problems with it. Like, it's not easy for all of us to deal with YAML, right? And these templates would be thousands and thousands of lines, like 20,000 plus lines of code to create infrastructure, and they would just do copy pasting, and it is tedious, right? Just a small typo, a small error can actually make you to go through the entire process again. And this was definitely tedious, right? I mean, it was easy to automate, it was reproducible, but then there is a lot of details, a lot of copy pasting, and it's just tedious to work with YAML, because not all of us are so used to working with YAML and JSON as a language. So then that led to development of document object models. Now these are like, for example, you may have heard of Troposphere, where you have your own languages. You can select languages and you can write the code in your favorite language that will convert into a JSON or YAML template that you can give to CloudFormation, and it will take care of infrastructure provisioning for you. So up to a point, this was actually helping you writing infrastructure in the form of code that you are familiar with, right? With common languages that you know. They still had few issues. I mean, this was good because now you could write in a familiar language. You could actually write code. You could write loops. You could write logic between applications. You could define different modules, define different classes, and the same principles. The way we are creating application, we would use the same principles for creating infrastructure now. So, and you go through the same stuff that you were going with your application, but there was still an issue. Like, for example, like the example I've given here, if you had to create a VPC, now VPC in AWS is like a networking infrastructure based networking that you need to create anything in the AWS platform. You must have a VPC. It's like a virtual private cloud that you define your IP range, your CIDR block, you define your IP range, and you can create resources inside this network. Okay. So that's why I'm just giving a basic example of VPC. I'm not talking about any complicated services in case you're new to AWS. So if you had to create a VPC, you had to define different subnets, you had to create different route tables, etc., etc. You had to actually write 200 plus lines of code in Troposphere to be able to do that. That is because there was no abstraction. The way CloudFormation is going to see it, you actually write the same kind of language in your Python application, because now the services provided that. So this is the major problem that CDK was trying to solve, where you still write your application code in your favorite programming languages, but with that you also get a lot of abstractions. So you write your application in the same programming language using CDK. You never leave your IDE, you never leave your terminal, you don't go to AWS console, you don't use any other tools to interact with AWS. You write code in your language that you're familiar with, or with CDK supports. CDK will automatically work with CloudFormation to actually deliver this or provision these infrastructure in the backend for you. So now you're writing your application in a familiar language, programming language. You're not working with JSON or YAML. You can then create many resources with just, I'll talk about constructs in the later slides, but you can define constructs and you can share this code with everyone else. You can do the same code review, or you can have your same testing workflows when you want to deal with code that is also creating your infrastructure and not just your application. And we'll talk a bit more in detail about CDK, but that is how the evolution is happening. And it's important to know why CDK is important. And that's why I wanted to take you through the journey. So let's quickly talk about CDK, right? CDK was announced in August 2018. It was in developer preview. Just last year, we went GA, that is generally available for a few languages that we announced last year. This year, we also announced the public roadmap. So if you're interested to know where we are taking CDK further, it's available publicly on GitHub. So go ahead and check it out. And this year, we also announced something called as CDK 8S, in an alpha stage with TypeScript and Python support. We will talk about CDK8, but CDK8 is nothing but CDK for Kubernetes. And if you try to understand what we are talking about is you don't have to deal with YAML code anymore, and you definitely do use a lot of YAML in your Kubernetes environments, and how we will talk about how CDKs will help you deal with that as well. And where we're going next, it's all in the roadmap. Go ahead, do a +1, contribute to CDK. We have a lot of people contributing back to CDK and CDKs, and we're doing awesome things. So if you're doing awesome things, just feel free to nudge me on Twitter or LinkedIn, and I'll be happy to connect you with the right people. So main components when you're talking about CDK, you have to remember 3 important things. First is the core framework, the construct library, and the CDK CLI. We will definitely talk about each of them in the upcoming slides, but remember there are 3 main components that you have to remember about CDK. The first thing is the CDK construct tree, or the core main CDK application. So when you use the CDK CLI to init or initialize the CDK application, you can define what kind of language you want to work with. Do you want to start with a sample application, or do you want to just start with a blank application? You define a CDK application, then you create 1 or more stacks in it. Now, these stacks are directly correlated to services like CloudFormation. Okay, so one stack that you define here will be like a CloudFormation stack. Okay, you define these stacks, and these stacks can have 1 or more constructs. Now, a construct could be an AWS service or AWS resource, like an AWS S3 bucket. S3 bucket is nothing but a storage folder that you would create in S3, right? So you could create either S3 bucket would be 1 construct, or you could have multiple constructs into one, like S3 and the CloudFront service, which is a CDN service. Those 2 are together 1 construct. So you could have either single construct or multiple constructs as 1 construct. So you define these different constructs in your different stacks that you're creating. Once you're done with your application, you can then use a CDK synth to actually generate the CloudFormation template. Okay, now you can either push this CloudFormation template through your code review, through your CI/CD pipeline, stuff like that, or you could actually use CDK deploy to not just create this CloudFormation template, but also push this to CloudFormation and let CloudFormation create your resources. Okay, so just taking another big picture view of the same thing that we discussed, you define your application, you define the source code, you use the CDK CLI to actually create, synthesize this, or synthesize, both commands are okay, to create a CloudFormation template. And you can also use CDK CLI to go ahead and deploy it to CloudFormation. Okay. The second important thing that you have to remember about CDK is the construct library. Now, while you can actually understand the properties and everything from the IDE that you're using, but if you want to have a go-to place of what are these different constructs, what are the languages supported, and how do I import them, what are the properties, what are the methods, all the information is available in construct library. Now, a lot of the default resources that you can create in AWS CloudFormation are defined as constructs already. So you can start reusing them in your application, right? You can just import them and start using them in your application. So these are available by default, but you can also create your own custom constructs, and you can also start sharing them within your different teams. We will talk, there are different levels of constructs as well. So we'll go a bit deeper into the kinds of constructs in the next slides. Quickly, it's a simple CLI. It's not too complex. So there are a few commands that you can run with. CDK Bootstrap is something that you just run once in every region that you're going to work with. Okay, so every region of AWS, you're going to do a CDK Bootstrap. It allows it to create certain buckets and certain permissions that it needs to work with CDK in your AWS account. CDK init, as simple as that. You can use it to actually create a template, like create an application from the templates, or create a library, or you could also just create a sample application using CDK init, right? Then you CDK init, and then you can add these constructs. Now, there are 2 ways to add constructs, right? One is either you say, one is at the terminal, you would say, hey, npm install this construct for me, and then it will install the required packages in your application. The second one would be you import the construct in your application code. Now, I just wanted to learn and play around with a new service, so a new language. So I started with TypeScript sometime a couple of months ago. So this is how you import it in TypeScript, but it should not be so different in other languages as well. And then I've used npm run bot somewhere in a background, in another terminal, just to keep compiling the code from TypeScript to JavaScript. Then you use CDK synth, which, as I mentioned, synthesizes and prints the CloudFormation template for the stack. And then you use CDK deploy, where you could use do the deployment in your AWS account. And of course, destroy and diff are, as the name suggests, you can differentiate between the different template files that have been created. So let's dive deeper into constructs a bit. So there are three types of constructs. Okay, there is low level, high level, and then there is a patterns, that is a third level of constructs. So the first one is low level constructs. Low level constructs actually represent the CloudFormation resources. So any construct that starts with CFN. So for example, if you see here, ec2.cfn VPC, that is a low level construct, right? It directly corresponds to the CFN resource in CloudFormation resource for VPC. So if this CloudFormation resource for VPC has a required property, like CIDR block is a required property for CloudFormation, then in a low level construct, you have to mention the CIDR block as a property. Okay, so let me repeat myself. If you have a required property in CloudFormation, you have to mention that required property in CDK as well. Okay, and because it's directly correlating to the CloudFormation resources, if you have to create a VPC, you define a VPC. If to create a subnets, you have to define the subnets. So similar to how I was talking to Troposphere, even if you use low level constructs, you have to define every component separately. You have to, and you define like how they are related, and you have to define everything, all the required properties in a low level construct. Okay. In a high level construct, it's the other way around. You don't have to define all the properties because it gives you few defaults for all these required properties, right? So all properties actually, not just the required properties. So if you don't give a property value, it will automatically pick it up from the default values that you have mentioned, and it will then and it will then start creating that resource. So for example, here, just this one line of code, right, saying, hey, VPC, ec2.vpc, create this VPC, will actually create a lot of resources. Like it will create the VPC, the public subnets, the private subnets, and everything that you would need as a best practice or by default inside a VPC. Right? And this is the powerful way of giving abstractions and giving you a lot of more details where you don't have to give a lot of details, right? So compared to the so many lines of code in low level constructs, in high level constructs, you would actually write less code and you would have convenient defaults. The third one is definitely patterns, where there are few patterns that are, we see normally customers using in the AWS cloud. Here I've given an example of ECS, which is one of our orchestration services for containers. But here I've given an example of how you can use a load balancer with a Fargate as a service, which is a common pattern that we see, and it will create all the necessary, necessary items around it. So there are something else as well that we announced called a solution constructs, which is also patterns only. So it's a same third type of constructs where you could see that, for example, API gateway and Lambda. If you work with serverless on AWS, there is a API gateway as a front end and Lambda as a serverless compute option in the back end. Now, this is a very common pattern that we have seen with customers, and we have created these pre-built, the solution architects at AWS have vetted these different patterns, and you can of course configure them, but they are like best practices, well-architected patterns, and you can just quickly use them in your application and start going. You don't have to actually write each and every code. You also have to remember the construct release levels, because many people ask, like, hey, can I use this in production? If it is a stable release, definitely you can. If it's an experimental release, I would really not suggest using it in production, but definitely you can test and play with it and see if it satisfies your problems. So let's quickly look at the demo that I have for so let me show you. So what I've done already as a good chef, normally as a good chef, I've already created few stacks because it does take time for launching resources in the AWS platform. But on the left side, if you see, this is the folder structure that we have for CDK itself. Okay, so this is a bin where I've written my main class where I can actually get started with CDK, right? I can use this this is like an entry point for my application. Then in the lib, I have defined different stacks that I want to create in the I can also define different constructs here, but right now I've just defined different stacks and I'm just using the default constructs that are available with CDK. If once you say like, hey, CDK synth, the CDK synth will actually create the CloudFormation templates or JSON based, or I'm using JSON, but you can also have YAML based templates here in the cdk.out folder. Okay, and this is me using VS Code. So you can see in VS Code, we also have Explorer in the preview mode. So you can actually see what are the different stacks I'm trying to create here. Like I have 3 stacks defined here, right? So you can see that base dev network, dev1, Apple, and Blueberry. So those are the 3 stacks I've defined. I even did CDK list, and you can actually see all the 3 stacks that I have defined. Okay, I have gone ahead and deployed. Of course, toolkit is something I've deployed already, but just last night I deployed the base dev network, which is nothing but simple. Let's go and let me show you this code. So it's simple 2 lines of code where I have just mentioned that create this VPC with 2 AZs. Okay, that's as simple as that. And this is the one that I have created. I don't know if I have okay, I have architecture later, so I can show you that. And what I've done here is I've created a Kubernetes cluster, and I've also launched that Kubernetes cluster. Let me see if I can show you that. Okay, so what I've done is base dev network, I've launched it, it has created. I never actually go to the console, but I'm just showing it in the console because it's easier to see in the AWS console. And let me do this. Let me go here. So I've not deployed the Apple one, right? So let's see CDK deploy dev1 Apple. Okay. And once I click enter, what is going to happen is that it will start deploying this into my AWS environment. So right now you can see there are a Blueberry, which has created few nested stacks, but now I'm hoping the demo gods are happy with me. But yes, now it is asking me a lot of permission related stuff. So I'm just going to say yes. And now it is going to start creating CloudFormation. So it's actually here, if you see, when I say dev1 deploy this, now this stack is actually dependent on the parent stack of the VPC. So there has to be a VPC before I can actually go ahead and start creating EC2 instances. So what it does is it actually goes and checks that does this stack exist or not. And because it exists, it will just go ahead and start deploying the dev1 Apple microservice that I have defined. So Apple microservice is nothing but an AWS EC2 instance. So I've just given few parameters for that EC2 instance. I've selected a virtual machine and I've started doing that. So you can actually see it also shows you a fancy, progress bar where you can see, hey, what is happening? Has it been deployed? If you don't want to see this, if you want to still go and check it out in the AWS console, you can also see that it's already started creating this stack in the AWS platform, right? Let me quickly show you something. Second. So what I've done here is Blueberry. Okay. So what I've done with Blueberry, now let this go down, is I have actually defined a demo user. Okay. I've created a cluster admin, manage policy. Okay. So I've created an EKS cluster. Now EKS at AWS is managed Kubernetes service, right? So it uses the same Kubernetes versions that are available. And we also have an upstream Kubernetes deployment, but I have defined a Kubernetes cluster. I've given it properties that, hey, I want the kubectl to be enabled. I want these certain properties. What should be my Kubernetes cluster's name? And then I've also defined an auto scaling group, which is like instances in AWS in a defined group. So I've said, hey, I want at least one instance in this group which has EKS optimized image, and I'm going to use it with EKS. And I've already launched that in my AWS platform. So if I have to go here, and I can show you that already it has created the EKS cluster, and it's currently using the Kubernetes version 1.17 and so on and so forth, right? And that's how easy it is to actually create application in CDK. You actually go ahead, import CDK, you import whatever services you need from AWS. Like I needed EKS, I needed auto scaling. I imported these services. I actually defined the CDK stack, right? A CDK stack has constructor with 3 arguments. So you define the scope of this stack, what is the ID of this stack, and what are the properties of this stack. I've just defined some properties that I wanted to pass, right? Then you go ahead and you define your different constructors. Now, in this case, it is a cluster where I'm defining an EKS cluster. And I've defined that EKS cluster to be here. Now, let me quickly see if there is a way for me to show you Blueberry. Okay. And this is what it creates. Now that just code, I do CDK synth, and it creates such a huge code. Now you can see how much scrolling I'm doing. And this is the JSON-based template that it has created, which has actually launched the cluster. It has launched a lot of other things. It has launched a lot of things, like it has launched the groups, it has launched the manifest files, it does a lot of authentication stuff in the backend, and so on and so forth. Now, the best part about working with CDK, right? Okay, so it has already launched this. Now it has told you, and this has been launched. Okay, let's go and check in this thing. Now just give it a second. And it will say, yes, stack complete, right? It's just been done right now. Okay, so best part about working with CDK is that you can define something called as assets. Okay, what you mean by assets is, for example, I want to work with Kubernetes and I want to deploy my own container image that I want to also create in the same application. Or if I'm working with a serverless application and I want to define my code in the same application, you can actually do all of that in CDK. You can package all of that into the same CDK application, and it will go ahead and bundle everything and deploy it to the cloud. Now, this takes a bit of a change in the way you're thinking about infrastructure, because now your infrastructure and your application code or your container images that have your application already are now all packed into one single way of deploying to the cloud, right? And if you want to just quickly roll back, you can always roll back to the previous version of your application, but now everything is now going together into the cloud. And this is a different way of thinking of doing, like, initially we used to only have infrastructure team doing their work, application team doing their work, right? Now, because everything is in the same programming language, or in the same, same programming language, but I can say the same application environment, you can actually package everything and push it ahead. And this makes it easy for rollbacks. Gives your team the trust that, hey, we trust you to do entire application, and it's a bit more closer to the DevOps principles that we have, right? So let me quickly go back. So what we actually saw was, there is an application that I defined. I showed you the folder structure. I showed you the different stacks that you can create, the different constructs that you can create. You can synthesize it. Like you could say, let me see. Could say CDK synth. Now it will ask me which one, but CDK synth, and it should be able to synthesize them into the CloudFormation files. And I actually did CDK deploy for the Apple microservice, and it went ahead and deployed it in the AWS console, right? So if you see this, it went ahead, and let's go and check out the resource. So this is the AC2 instance that it actually created, that I had defined in the Apple microservice. Okay. And that should be, and you can see that this just okay, and you can see that this was just launched. I don't know where the timing is. Okay, launch time is right now. Okay, so 3 minutes ago, we actually launched this instance. And that's what it is. I have to work with the code, the terminal, and just VS Code. I don't need to go to the AWS console at all if I have to work with my infrastructure and with my application. So what happened is this just one command, VPC new ec2.vpc, the one I had actually launched last night, because it takes around 20 minutes to actually create all these resources, because there's a lot of dependencies between these resources, and there's a lot of checks that CloudFormation has to do. If something has failed or not come back, the API has not yet come back, it will wait and keep doing retries. So it takes about 10 to 15 minutes at least for deploying so many resources that are independent to each other, right? And I just wrote one line of code. I didn't have to write so many lines of YAML or JSON code. I just had to write one line of code and it did all that for me. So this one line of code actually did a lot more for me. So if you are like me, and you understand architectures better, this is AWS Cloud. In AWS, it will go ahead and deploy the VPC, the public subnets, the private subnets, the NAT gateway, the elastic IPs for the NAT gateway, the route tables, associate them, and internet gateway and associate them. So that one line of code has done a lot of work in the backend for you. And if you've worked with AWS, you'll understand that how much work this has done, that single line of code has done, and the power of using this in your applications. So to summarize, you can now define these abstractions and reuse and share them within your company. You can actually create these construct sets, templates, and best practices, right? And you can now make your teams, like if you're going towards microservices environment, you can make your teams use these in your and continue doing that. You can also contribute back to the CDK world and share these best practices with others as well who are using CDK. You can, definitely everything you're doing is from the IDE. You can now use real code. You can use logic. You can use your object-oriented techniques. I already talked about how you can use your same testing standards for testing your infrastructure and not just the application. And you can also go through the same code review workflow when you're for your infrastructure. There is another open source project that you may be interested on. This is called as JavaScript Interoperability Interface. Sorry, that's a tongue twister for me. But this is what has made it easy for CDK to deliver polyglot libraries from a single code database, right? So just using one code database, now we are able to support so many different languages. And if you're interested, you can just go ahead and check more about JSII. I have 10 more minutes, so let me quickly wrap through the CDK8 or CDK for Kubernetes. Unlike CDK, which is for AWS community, CDK8S or CDK for Kubernetes is for the entire Kubernetes community, right? It is not just dependent on if you're creating it on AWS or not. Wherever you host your Kubernetes environment, you can use CDK8. You can support any Kubernetes API versions. You can create different custom resources. While it is alpha today, there are a lot of things planned. You can check out the roadmap on GitHub. It's available for you to view, to contribute, to do +1, whatever you're interested in. So similar to CDK, CDK will have an application, right? You will define or initialize an application in CDK. You create different charts. You don't create stacks here. You create different charts in the CDK application. You then define different constructs, okay? And here, your constructs will not be AWS resources, right? Because you're not dealing with AWS anymore. You're dealing with Kubernetes. So your constructs will now be your pods, your services, or your deployments that you want to deploy into Kubernetes environment, right? So these would now be your constructs that you define. Once you do CDK8 synth, it will actually create the Kubernetes manifest file, which now you can give to Kubernetes and you can use kubectl to actually go ahead and deploy the Kubernetes resources, right? I don't want to spend a lot of time in the demo, but let me see if I can show you something quickly. So this is the code for CDK8. The same way I'm defining a chart, not a stack. The same principles for constructors apply here as well. If you see on the right side, you can see that it's where is it? Okay, so there is a distribution channel where I've actually, no, I'll just go here, and what I'm showing in the code is I've defined a label. I'm saying, hey, hello kids, and I'm defining a service. Okay, so let me show you that service. Now the service is simple. It's a load balancer with certain port, and it has a certain label that we've already defined. I'm also creating a deployment using a available container image, and I'm actually showing that, hey, I've just deployed it using containers. The minute I do CDK synth here, it will actually create the YAML file that I need to deploy. So if you work with CDK Kubernetes, you will understand this is the YAML file that Kubernetes expects for you to write, right? I've not written all these things, but these are automatically picked up by the CDK, right? I've only defined the load balancer and the label, and it has already picked up all of that, and it has created in a format that is accepted by Kubernetes today, right? And if I have to deploy it, I just have to do kubectl apply apply -f, and then I just mention the file, and it will go ahead and apply it to the Kubernetes cluster that you have defined or configured in your environment, right? So quickly, CDK application, the core framework, that is your source code. You use CDK CLI to actually compile it, and you create or synthesize the Kubernetes manifest file. The example that I showed you is a quite small one, right? But if you're working with Kubernetes, you know how complex it gets, how many different files you have to work with. If you could just create all of that in a language that you're familiar with, it becomes much, much easier to work with when it comes to CDK, right? Then, so a simple example here is the same one that I had showed you, hello CDK at C8, and that created this code. So to summarize, it's an imperative approach to writing a declarative state. It works for any clusters. It's open source. It's for the entire Kubernetes community and not just AWS customers. And there's a lot more languages that we want to support in the future. If you want to contribute back to the CDK project, definitely there's a detailed information available on how you can contribute back to the project itself. Go ahead and check it out on GitHub. It's all published there. And for next steps, if you want to engage more, it's already available on GitHub. That's what I've said. There's also a GitHub community. There's also a workshop. So if you are a person who likes to do hands-on stuff and you want to, play around, but you want some step-by-step guidelines on how do I do it, there's a beautiful CDK workshop which you can follow through and create your own CDK project. CDK has its own different website, so you can also go ahead and check it out at cdkeds.io. Before I close it, I do want to tell you there is an awesome, this is by a personal project. It's not by AWS or Amazon. This is a personal project. And he has this collection of awesome stuff that customers have been doing with CDK, right? And he's just collected all of that. And there are so many wrappers, there are so many things that they've created to be able to create AWS environments with best practices, with a lot of tips and tricks, and with ease on the AWS platform. Right. With that, I'm coming to an end to my presentation. Feel free to reach out to me on Twitter, on LinkedIn. I do have my YouTube channel that I've just started recently. But if you want to know more, feel free to reach out to me.